Hello grade 6, this is Mr. Brocklehurst speaking here. I want to introduce you to how to determine the mechanical advantage, the effort force required, and its impact on pulling distance for single string pulley systems. So this works for any pulley system that operates off of a single string. If there is more than one string, I have two things to say about that. First is that it's beyond the scope of this grade 6 science course, and second, that you will not be given any questions with more than one string in it in this class. So for single string pulley systems, if you look at the figure to the right, you will see that there is only one string wrapped around multiple pulleys. To find the mechanical advantage, I recommend using what I call the circle and sword method. Our first task is to draw a circle around the load and any pulley that is attached to the load and moves with it. If the pulley does not move with the load, it should not be included in the circle. In the figure to the right, you will see me draw a circle around the load and the bottom pulley that the load is attached to and will move with the load. I am not including anything else in this circle. I don't want to include the fixed pulley up above, and I'm not including the effort either. At this point, you should draw this exact circle as well. As I mentioned at the beginning, this is called the circle and sword method. We have now finished with the circle, and it's time for the sword. Our sword moves around in that same circle, and we want to count the number of times it cuts a string as it moves in that circle. As you can see, in this case, it will cut the string in one and then two places. I'm numbering them as so, and you should too. That means that this pulley system has a mechanical advantage of 2. Write that down on your page. What does this mean about the effort force? That means if the load is 100 grams and our mechanical advantage is 2, the pulley system makes it twice as easy for us to lift the load. How much effort force do we need if it's twice as easy? Take a moment and tell your neighbor how much effort force is needed. Pause the video now to have that discussion. If your neighbor told you 50 grams of effort, you are very lucky indeed to be sitting next to such a clever neighbor. Pat yourself on the back for being so lucky. Furthermore, what effect would this have on how much string you need to pull? Well, if the load is lifted 1 meter, since you have only half the effort force, that means you should have twice the distance. Remember, we are always trading force for distance. So, you will need to pull 2 meters of string in order to raise the load 1 meter. Okay, let's go back up and fill in letter B at this point in time. A supporting string is one that supports a movable pulley or the load. Okay, I apologize for the lack of space there. You can fill it in down below if you need to. Okay, let's try out number 7 at this point. Draw your circle around the load and any movable pulleys that move with the load. Take a moment and draw your circle now. Pause the video if you need to. As I draw my circle, I include these 2 movable pulleys but not the fixed pulleys above. And as I move my sword around the circle, I cut it in 1, 2, 3, 4 places. That gives me a mechanical advantage of 4. As always, thank you for listening today. I hope this was helpful. Please subscribe, hit the thumbs up, and smash that bell so that you don't miss out on any further videos. Talk to you soon.